Okay, let's continue exploring polynomial functions, which again are comprised of power functions of x. And we're going to really be exploring the end behavior and what happens at the end behavior. So in 5a, we are looking at this function x squared. M of x is x squared. And we want to choose all of the functions in these selection, a through f, that have the same end behavior, right? Meaning, is it approaching infinity, negative infinity at the end, at both ends, as x gets infinitely large and x gets infinitesimally or infinitely large in the negative direction. So what you're looking for are just even powers of x that have a positive coefficient. So even powers of x that have a positive coefficient. So far I see this one, positive coefficient, even power. This is a even power but a negative coefficient, so all the values will be negative. This is an odd power, so this is going to have some live in the negative and the positive. Right? We want something that's only positive. Remember, x squared is only positive. So x to the 8th is always positive, so this is going to have the same end behavior as well. And again, this is a negative of an odd power function. So the only two functions that will have the same end behavior as x squared is 9x to the 6th and 5/3 x to the 8th. Now we can explore this in graphing in Desmos. You can see in this graph we have x squared graphed, right? And if you look at negative 1/2 x squared, you'll see it's inverted, so it doesn't have the same end behavior, right? In x squared, we're going to positive infinity on both sides, right? As x gets large, this is just skyrocketing up to infinity, and these are both going to negative infinity, so they don't have the same end behavior. Let's check out 9x to the 6th. Notice it's positive, even powered. They're both going to positive infinity, so ultimately these two do in fact have the same end behavior. Negative 3x to the 4th is going to have the same problem as negative 1/2 x squared. It's going to be all negative, right? So it's kind of similar to that, right? Concave down. 2x to the 5th is going to have be an odd function where some of it is positive, some of it is negative. This one, however, you'll notice, has the same end behavior. As x gets infinitely large, this thing's going to go up to infinity, albeit it seems like it's going a lot faster, right, than x squared. But you can see all three of these have the same end behavior. The last one was for negative 4x to the 7th, which again is going to look sort of like 2x to the 5th, only reflected. Okay. So now in part B, we can do a similar analysis, right? So we have a negative x squared. So we're going to look for even powers that have a negative in front of them. So you can see this has a negative coefficient and it's an even power. There you have it. This has a positive coefficient and even power, so this is not going to work. Negative coefficient and even power. That's good. This is an odd coefficient, not going to work. In fact, we can knock off these two because they're odd coefficients. We could also knock off this one because it doesn't have a negative coefficient. So you can tell by whether the power is even or odd, and by whether the coefficient is negative or positive. Okay, and there's a few more exercises regarding this. Let's look at x cubed now. This is an odd function, right? So we're going to look for positive coefficient odd functions. And you can see I have a positive coefficient odd function here. Nowhere else do I see one. Okay, so everything else is not going to match up. Even, 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 And this is odd, but it's a negative coefficient, so it's going to be reflected. So it won't have the same exact end behavior. Now, this one, as x, just to be clear, right, and for this function, as x gets infinitely large, the function 2x to the fifth is going to get infinitely large, right? But as x gets close to negative infinity, this is going to go to negative infinity, because a negative number raised to an odd power is still negative, right? So this is going to be inverted down here. So for this guy, right, as x goes to positive infinity, this negative 4x to the seventh is going to go to negative infinity, because x will be positive, but you'll be multiplying by this negative 4. And then similarly, like as x goes to negative infinity, this will be like negative 4 times negative infinity. So it'll be a positive infinity, right? So it's similar, but they're not exactly the same. It has to be both a positive coefficient and the same parity in the exponent, either even or odd, okay? And let's look at the last one, D. We have f of x equals negative 1/2 x squared, and we're comparing that to negative odd power. So we're looking for a negative odd power. So right away we can knock off, get rid of this. This is an even power, even power, even power. This is a positive odd power, so that's not going to work. They're going to be reflected. So the only one that will have the same end behavior would be this negative for x to the seventh. So I encourage you to explore the behavior of polynomials at using Desmos. You could just graph it like I did a moment ago, and just check out what happens to as you change the exponents and the coefficients. So you might have gathered that really when you're looking at a polynomial, the only thing that matters when looking at the when examining the end behavior is the leading coefficient, right? So we're interested in just the leading coefficient here. So if we want to know which of the functions has the same end behavior as this polynomial, 2x cubed minus 6x squared plus 2x plus 3, we don't even have to consider all of these other terms. Those are kind of extraneous. As x gets infinitely large, or in the negative direction or positive direction, the rest of these terms will be overshadowed by the leading term. And so this will be the dominating term, and this is the only thing that we really need to worry about when examining end behavior. So really what we're looking for is a positive coefficient and an odd power, and they will have the same, that polynomial will have the same behavior as this one. So we're going to look at the leading terms for these polynomials. So the leading term here is 13x to the fifth. 2x cubed is not the leading term, even though it's in the first spot. Notice the leading term here is going to be negative 6x to the fourth, because 4 is the highest degree. Then negative 17x squared is the leading term. The leading term in D is negative 1/4 x to the fifth. This only has one term, so that's the leading term, and then the leading term here. So we're looking for, we want to match this term in terms of its positive coefficient and odd power. So which one has a positive coefficient and odd power? Well, A does. That will have the same end behavior. B will not, so B is no. C is even. Again, this is odd, but it has a negative power, so it will not have the exact same behavior. E is odd and positive, so that will work. And finally, F is not going to work because it's even. Okay, So again, you really only have to examine and compare the leading terms and match them for the sign of the coefficient and whether or not the power is even or odd. Okay, so let's just do a quick summary here, right? For even functions, for even power functions or even leading coefficients or leading terms, the end behavior when a is positive is always going to be positive infinity, right? So as x goes to infinity, we know the function is going to go to infinity as well. As x goes to negative infinity, the function is going to go to infinity, positive. So this always goes to positive infinity for end behavior, okay? If a is negative and it's even, then just the opposite happens, right? As it's going to go to negative infinity. So as x goes to infinity, f is going to go to negative infinity. As x goes to negative infinity, f is still going to be negative because it's multiplied by a negative number. So this is going to go to negative infinity in general in either direction. And when the degree is odd and a is positive, well, as x goes to infinity, we have the polynomial is going to go to infinity. However, when x is negative, as x goes to negative infinity, the function's also going to be negative because if you raise a negative number to an odd power, it's still negative. Okay, so this goes to plus or minus infinity. Okay, depending on which side you're going to. And likewise, this one has just the inverse here. So it's as x goes to infinity, f is going to go to negative infinity, and as x goes to negative infinity, f is going to go to positive infinity, so it's again plus or minus infinity. Okay, so that's a summary of the end behavior. Hopefully this is starting to make sense. Well, let's do one last example to help conceptualize all of these concepts. We're going to look at a particular polynomial function here, negative 2x to the fourth plus 2x cubed minus 4x squared. You can see the leading term is negative 2x to the fourth, right? So we know x is always going to be positive because it's an even power. Therefore, everything is being multiplied by a negative number, so it's going to look like a concave down, right, graph. And it's, well, the end behavior is going to be sort of concave, like a concave down graph in the sense that it's both going to negative infinity. So as x goes to negative infinity, f is going to negative infinity. As x goes to positive infinity, this is going to negative infinity, right? So again, we just have to worry about the leading term. So we look at the next one. Okay, we can see it's a positive coefficient odd power. That first power term in the polynomial, that first power series, the graph would look something like this, right? So we have when x is positive, it's going to positive infinity. And when x is negative, it's going to negative infinity. So if x is going to negative infinity, the function's going to negative infinity. If x is going to positive infinity, the function's going to positive infinity. Okay? And in this next one, you can see we're not going to multiply this out because we know this is going to have an x squared in it, right? You have a negative 1 out front, right? You're going to have an x squared. And when you multiply this all out, there's going to be an x to the fifth power there, right? And eventually, and then you're going to be multiplying these two. So the leading term is going to be this. It's going to be negative x to the seventh power. That will be the leading term. So it's a negative of an odd function. So instead of like this, it's going to look something like this, right? Instead of like b, it's going to look like this. So we can see the degree is going to be 7. The leading coefficient is negative 1. as x goes to negative infinity, this one actually goes to positive infinity. And as x goes to positive infinity, this is going down to negative infinity, right? You can see that. As you go this way, it's going up to positive infinity. And as you go down this way, it's going to negative infinity. Okay. And we can do one last problem. Okay, so now we're squaring this whole thing. So there's going to be no negatives. And so really the leading term will just be the square of negative 4x cubed, right? Square that. You're going to get 16x to the 6th power, right? So it'll be a 6th degree polynomial. The leading coefficient is 16. So it's an even power with a positive coefficient. That means it's going to always be positive, this function. So as x goes to negative infinity, this is going to positive infinity. And as x goes to positive infinity, it's also going to positive infinity. So it looks like this function would look something like this, right? Going up to positive infinity and positive infinity. Okay, I hope this was helpful. Hearing me walk through these problems. Let me know if you have any questions on this. Thank you.